Welcome to Study Loop.
So we know that we're going from the n equals 3 state to the n equals 2 state. So the energy values of these different n states are given by E sub n is equal to negative 13.6 eV over n squared. So E sub 2 is negative 3.4 eV, and E sub 3 is equal to negative 1.51 eV. For A, the shift in the energy level from the zero field value, delta E, is equal to mu sub B times the magnetic field strength B. Mu sub B is just a constant 5.78 times 10 to the minus 15 electron volts per Tesla. And we're told the magnetic field is 1.4 Tesla. So this comes out 8.1 times 10 to the minus 4 electron volts. Now for part B, to find the wavelength, we're going to consider the fact that E3 minus E2 is equal to E, or in other words, E3 minus E2 plus delta E. Plug those values in, what we found for delta E, what we know E3 and E2's value, we get a value of 1.89 electron. So now that we know that, we can do change in wavelength here. So lambda minus lambda prime is equal to delta that same note. So lambda minus lambda prime, in other words, delta lambda is equal to hc, so because lambda is equal to hc over E. So we have hc times 1e minus 1e prime or we lower algebra, we write this another way. So hc times E prime minus E over E times E prime, or E over E times E prime. So we have this being equal to hc times delta E over E squared, if E is equal to E prime. We're going to say E prime, and we're calling E 9 electron volts. We calculated at the beginning is our E value, the energy difference, plus the zero energy level field. So we know delta E as well, because delta E is our 8.1 times 10 to the minus 5 electron volts. I wrote 10 to the minus 4, so this is supposed to be 10 to the minus 5. So you might have caught that mistake. So 8.1 times 5. So delta E value is the delta E value that we're using, and the E value we just calculated above is the E value we're using. And of course, H and C are just Planck's constant and the speed of light. So you put those values in, and this is equal to 0.0281 times 10 to the minus 9 meters, or 0.002 nanometer. I'm going to write in some nanometers, but you could already write it as 10 to the minus 9 meters, since both are correct and equivalent. Box that in a solution for B.